of circles, children, is that area is always measured in what, Gabe, shoot? The label for area is always in what? Square units. You ever heard that phrase that says you can't put a square peg through a round hole, or maybe it's a round peg through a square hole? No, it'd be a square peg through a round hole, I think. Okay, area is always measured in these little square units, whether it's a square inch or a square foot or whatever. And if you look at a circle, how do you cut that into squares without having like pieces with round corners? How do you take this thing? You know, with a rectangle, it's really easy because it's got square corners, so you just divide it up like that. You got nice square units. But how do you take a circle and cut it into squares? I mean, I can get some nice squares in it, but what do I do about all these round little chunks of pieces over here that aren't? How do I call that square units? Point you guys. Good point. How do you do that?
You can cut the circle into a big square.
All right,
And then
so
cut that piece.
how does that solve your thing? All right. Here is, though, your mindset here. And I did this. Let me get rid of this little thing here. Here is what some person, and it wasn't me, thought about doing. So here's my circle. I now just cut it into pie pieces. Okay, there's still round corners there. But if you manipulate this, which means move it around, if I were to take my little pie pieces and do this, I'm going to move this one over here, and then I'm going to take this one, I'm going to move it over here, but I'm going to flip it over and put it next to it like such.
No way.
I want to get it better than that. Hold on. And I take this one, flip it around like this, and put it next to that one. This one still isn't quite right. I guess I'm just going to leave it like that because I can't. Oh, maybe I can do it better. I can't get it just right. Take this one and move it over. Right, and move this one over. Take this one and move it over. If I could do this without this board and actually do it just right, and if I cut these into small enough pieces, what shape will I actually end up with? If I keep doing this and doing it for all the circle, I'm going to end up with, Brianna, a rectangle. So I can change my circle and make it a rectangle. The problem is, I need to figure out, because I know a rectangle, to find the area of a rectangle, I do the length times the width, or base times height, or whatever it is. How could I figure out what that is? Well, this is easy. What is this measurement from here to here? If you look at my circle here, what do we call that? The distance from there to there, which is that distance there to there, is the what? Somebody, Isabel?
Radius.
Okay, so let's write this down so far. So we got area is going to equal length times width, and I know my width is the radius. Jill, I'm not going to compete with you. Alright, I know my width is the radius. What is the length going to be? Well, notice what it is. I got my circles. I keep alternating one side to the other side. If I were to add up all of these, right now they're little round pieces, every other one of them, what is that? All those little round pieces. Jaden? It's the circumference. So, but it's not really the circumference, it's only half the circumference, right? Because half the circumference ends up on the bottom and the other half ends up on top. So my area equals what I get when I multiply the radius times half of the circumference. Now, you don't like that because it's got a fraction in it, but we're going to change that. I can change circumference because I know the formula for circumference. What is the circumference? Anybody? Brooklyn?
There's no 1/4.
No, that's pi.
It is pi, but this isn't pi.
It's in there, but I need to know what the formula for circumference is. How do you find circumference of a circle? Elijah?
Radius by
Circumference of a circle is, Kara? Diameter times pi. So here we go. I'm going to put that in for the letter C because that's what it is, but I'm going to do it in a different place so that you can actually see it and I can work with it a little bit. So here we go. Check this out. Make this bigger. And make this smaller. Okay, so here we go. I had this, which is my area formula, but I'm putting this in for the letter C right there. So it's going to look like this, and then in the end you'll ooh and ah because it'll be really something really in the end, not now. Area equals the radius times 1/2 of diameter times pi. No, not yet. Now let me ask you a question. What is half of a diameter? Oh, look at Christ. Half of the diameter is the same thing as radius. So my area for a formula for the area of a circle is area equals radius times pi. Or usually people say it like this. Area equals pi r squared. Pi times radius. That's the formula for the area of a circle. And that's what you need to remember. None of this stuff that I did up here really matters. You just need to write this down for the formula for the area of a circle. But that's how they did it. They took a circle, cut it into really small. If you could do it in super tiny small pieces and change them and flip them and mix them all, put them up, it would look like it would end up being a perfect rectangle, in which case this formula is good. So area equals pi times radius or pi r squared. So all you need to know is the radius of a circle. If I know that my radius is 10 inches, how do I find its area? Well, I write down this formula and I do pi, usually we call what? Let me see. Does it tell us to use 3.1? Yeah. We're just going to use 3.14. I don't know why I put 5. 3.14, what's the radius of my circle? 10 times 10. And hopefully this is something I would hope that you could do in your head. It doesn't matter the order when you multiply. 10 times 10 is, what's 100 times 3.14?
314.
There you go. Area equals 314. 100, remove the decimal 2 places. And this is square inches or whatever it is. Inches squared. Just make sure you have this formula written down for the area of the circle. Pi r squared. That is where it comes from. So one more just from the book here. It says calculate the area of a circle with a diameter of 2 feet. Area of a circle, just so you know what I expect of you, with a diameter of 2 feet. So if you see this problem in the book, first thing you would do is do what, Riley Harrington?
You would
Draw the circle, did you say? That's perfect. You draw your circle, label the diameter, which is what? 2 feet. 2 feet. Next thing you would write down is, Elijah?
24 inches.
Formula, what?
Area equals 5 times radius.
There you go. Next thing you write is the formula for the area of a circle. Area equals pi times radius or pi r squared if you like, either one. Then you would fill in the blanks. You know that pi is 3.14. Radius is, it is not 2 feet, 1 foot. And it doesn't get any easier than that math. What is 3.14 times 1 times 1? Area equals 3.14 feet squared. And why is it square feet? Because both of these ones are a measure of feet. It really should have been 3.14 times 1 foot times 1 foot. Foot times foot is feet squared. 1 times 1 is 1. And that, ladies and gentlemen, is how you do area of a circle. Isn't that exciting?